Hello, I'm Shuhei Takahashi from Chrome OS Velocity team in Tokyo. And this is the last session in the Chrome OS software track today. So today I will talk about integration testing Chromium OS with Tast. So as you may already know, please submit your questions if you have any to slide.com from the URL and event code shown in the screen. So let us start from some brief introduction. First, let me start with categorization of tests. So in this talk, I will categorize tests into three: unit tests and integration tests and manual tests. I know there are several other ways to categorize, but in this talk, I will use these three categorization. First type is unit tests. They are most popular, and they test very smaller components of a system, like functions or classes. Unit tests run very fast, like in the order of milliseconds, and deterministic. So we can write a large number of test cases. That's very nice aspect of unit tests. On the other hand, unit tests can catch complicated issues spanning across many number of components. And integration tests exercise system as a whole. Compared to unit tests, they interact with many components at once. So they are slower and often less deterministic compared to unit tests. But on the other hand, integration tests can catch much more complicated issues that can't be caught by unit tests. And also there are manual tests, obviously, that they are tests performed by humans. They can catch issues missed by automated tests, but they are very costly. The diagram shows the hierarchy of tests. So lower layer have property of more faster and deterministic, and they have more test cases. In upper layers, they are more capable of catching complicated issues, but usually they have less test cases. So to write those tests, we usually use a framework. And for unit tests, in Chromium OS, we usually use this GTest, Google Test, for C++-based programs, and maybe other frameworks for other languages. And today I will talk about Tast, and it's focused on integration tests, the middle layer. So we want to do integration testing of Chromium OS, but it's a bit different from integration tests of other software products like web applications, because we do remote testing. In remote testing, there are two machines involved. One is a real Chromebook device that runs Chromium OS. They are often called device under testing, or in short, DUT. And there are another machine called just host. A host is typically a usual Linux machine. And a host accesses the DUT by remote access. So why do we use these two machines? There are several reasons, but one reason is that some test cases have to reboot the DUT to perform test scenarios. For example, if a test needs to exercise enterprise policy-related scenarios, they first have to enroll the device into enterprise policy. And enrolling the device to enterprise policy requires rebooting. If the test program is running on the DUT, it's very difficult to reboot the machine itself. So in such case, the test program will run on the host instead and use remote access protocols like SSH to reboot the DUT. And for example, another reason is that in some cases, test scenarios need external peripherals attached to the device to perform a scenario. For example, DUT might be attached with a special hardware injecting hardware key strokes. In such cases, we need control from outside of the DUT. So framework we use for Chromium OS should support remote testing. And there are two frameworks we use for Chromium OS integration testing. First one is Autotest. It's an open source remote testing framework. It's actually originally developed for testing Linux kernels. And it's been used since the very initial release of Chromium OS, and we have a lot of existing tests. And since 2 years ago, we got a new framework called Tast. It's a remote testing framework dedicated for Chromium OS. And that's I'm talking about today. While we have two testing frameworks, both of them are actively used and supported. So it is up to test authors which framework to choose. So why did we develop Tast? So there are two primary focuses of Tast. One is speed. Tast is designed to minimize the runtime of testing. So its framework overhead is very minimal. And it provides several framework features to intelligently schedule tests to minimize testing time. So I'm afraid I can't go into details about this today, but yeah, there are several useful features. And another aspect is maintainability. Tast provides many static analysis that catches bugs very early. So Tast tests are written in Go, and so Go program comes with static type checks, and also we have a lot of custom lint rules that helps you to catch bugs very early. And Tast has documented best practices that is available from the website. I put a link to the documentation in the end of the slide. And Tast has streamlined code review process. We have a set of reviewers who are experts of Tast tests, and they are happy to review our changes. So summary of this section is that Chromium OS has two remote testing frameworks, Autotest and Tast. And Tast is a new framework focusing on speed and maintainability. So let's go quickly about how test works before going into details about Tast. I will demonstrate how to run and modify a Tast test. First, to run this quick start, you need a Linux machine with Chromium OS source checkout. and also with Chromium OS root that can be created with Cros SDK command. If you have worked on Chromium OS, you might already know them. And you need a Chromebook device flashed with a test image. So running a test is very easy. In Chromium root, please run tast run command. Its first argument is the host name of the machine, in this case IP address, and the second and further argument is test name, in this case example path. Example path is a test to test that does nothing and always passes. So let's see what happens. So the command basically builds the test into executable and push the executable to the DUT by SSH and runs the binary. In the output, you see the test started and finished immediately. And at the bottom, you see the summary of test, in this case, only one test case. And more detailed results are saved to the temp directory. And let's see the detailed test result directory. Temp task results latest is a symbolic link to the latest run results. And the directory contains several files. Some interesting files are, for example, foo.txt contains a complete copy of task run output. System logs directory contains system logs gathered at the end of test run. And test directory contains per test detailed results. So let's take a look at results of example path test. And it contains only two files. Log text contains logs emitted by test scenario itself. And if a test failed, error message will be included in this file. And messages is a subset of syslog emitted during testing. So next, let's try modifying the test. This is a file implementing example.path_test. It's located at the path indicated above. It contains two functions, init and path. Init is a reserved function name in Go, and the function runs on the very beginning of executable. And it contains only one function called testing as test, which registers the test metadata to the framework. So the test struct literal you are seeing in the screen, basically metadata of the test. I will go into details about this later. And another function you see is function implementing the test scenario itself. It's empty because example path does nothing. So let's try to modify this test. So this is an example test. So it calls basically just two functions. First call is chrome.new, which restarts Chrome and logs into a new user session with a fake account. And then after some error handling, it calls newCon function, which opens a new tab with a specified URL. So let's see what happens with this code. So the Chrome is restarted and the sign-in window is shown, and it is kept automatically with a fake account. And finally, the specified URL is shown. So this is a quick summary. So Tast tests are written in Go, and we can use Tast run command to build and run Tast tests. And now that we've seen how to build and run Tast tests, let me explain basic concepts in Tast to help you understand what we did in the previous sections. So this diagram illustrates the high-level architecture of Tast. Tast consists of 3 layers, tests and support libraries, and core framework. So, and they interact each other. I will explain those components one by one. First, tests. So, as we already see, tests it consists of 2 elements. A Go function implementing the test scenario, and its associated metadata. Metadata contains several data like test name or description of the test, or contacts to be contacted when the test is failing, or timeout of the test, and a few attributes that I will cover later. And second layer is support libraries. It is a collection of shared libraries that is imported and used by tests. One good example is a Chrome package. We already saw the usage of this package in the earlier example. Chrome is a package to control Chrome via DevTools protocol, and it is used by many tests, many existing tests. And we have a lot of support libraries like control Android or controlling Cros. And third layer is core framework. So the Tast core framework lies between test and testing infrastructure or user. It provides Go API to Tast tests and support library. On the other hand, it provides command line to build and run tests, Tast command to testing infrastructure and users. And it does many logistics like registering tests and providing API or enforcing timeouts, gathering system logs, or saving results. So to recap, there are 3 big components of Tast. And actually, those 3 components are split into 2 Git repositories. Core framework is managed in a repository source platform Tast, and the other components are included in source platform Tast tests repository. So in most cases, you only have to touch code in source platform Tast test to work with Tast tests. Okay, so let's go a bit deeper into tests because it is likely you are most interested in them. On adding a new test, you have to think about a few key properties to decide a file path to put the test and test metadata to put in the test. And here is a list of key properties of test. Local or remote, and category, and bundle, and groups. So let me explain them one by one using this example test. It is a test named ui.chrome login. And it is basically the same as example test we wrote in the previous section. It just logs into the Chrome and make sure the browsing works. And let me explain key properties of this test. First property is local or remote. In this case, the test is local because the file path contains local instead of remote. So what are local tests and remote tests? As we discussed earlier, Tast is a remote testing framework. So basically, test process runs on the host instead of the DUT. This is necessary to reboot the DUT or accessing external peripherals. But in the other hand, running every test as remote test is not convenient because they don't have direct access to the file system on the DUT or sockets available only on the DUT. For example, to control Chrome, we have to connect to Chrome by socket, but they are not immediately available. And actually, most tests don't need to reboot the DUT or access peripherals actually. So in such cases, we can write such tests as local tests. And local tests binaries runs directly on the DUT. This is usually convenient for most tests, and we recommend writing your test as local tests whenever possible. If a test needs to reboot the DUT or for other reasons, it cannot be cannot be written as local test, only that time we can write them as remote test. And second property is category. So it's actually a directory name containing the test code, in this case, UI. So there is a naming convention in Tast to enforce some naming. Let's say we put the code in UI/chrome-login.go. Then the name of the test is like UI.chrome-login with camel case. And also the function that implements the test scenario should be Chrome login. This relationship is enforced by lint rules. So yeah. And property 3 is bundle. So in this case, Cros is a bundle name. Actually, it is rare that you have to use different bundles than Cros. So please just think that we always use Cros as a bundle name. For private tests, we need to use different bundles. And finally, groups. So groups is defined by attributes included in test metadata. In this case, it has group main attribute. So what are attributes and groups? A test can declare 0 or more attributes. And attributes with group prefix defines groups. For example, if a test has group main attribute, then we can say the test belongs to the mainline group, and we call such test as mainline test. And mainline group is a group for functional tests. And we have other groups like crossboard group, which contains performance tests. And we define other attributes that qualify groups. For example, if we set informational attribute to our mainline tests, we can mark them informational tests. If our mainline test lacks informational attribute, they are called critical tests. Such attributes are used to select tests to run. So Tast command accepts the attribute expression that selects tests by attributes. So for example, on commit queue pre-submit test, we use this expression to select and run a critical test. So basically attributes defines when to run those tests. So this is a summary of key properties. So first and most, local or remote is the most important property. Should it run on the host or DUT? Please always prefer DUT whenever possible. And we have to decide category by which Chromium OS feature the test exercise, and decide bundle by who can access the test, and groups by the purpose of the test. Okay, this is a final exercise. Let's think about adding a new UI functional test. In this case, is it local or remote? It is likely local unless the test uses external peripherals or reboot the DUT. And category would be just UI. And bundle should be just Cros as long as it's a public test. And groups would be mainline because it is a functional test. After deciding these key properties, we can decide the file path. It would be file path like this. And attribute will contain group mainline and informational. Okay, that's all from me. And here are the differences. So the documentation is available at this URL. It contains code labs, guides, and references. So if you want to write test tests, please take a look at them. You can reach to the site by searching Chromium OS Tast. Yeah, that's it from me. So thanks for listening. And if you have any questions, please submit to slide.com. Mhm. Yeah. Yeah. So the question is, what's a fake login? And does it guarantee that Chrome will open from scratch? So a fake login uses a fake account that is not tied to real Google account or any internet account. And using a fake login, yes, this is right. We can guarantee that the Chrome will open from scratch. So it's a library of package to review. So in the Tast test repository, there are many support libraries. So I think it's good to take a look at them. And most popular packages are listed in a previous slide: Chrome package and Arc package and Crostini package. And there are many other support libraries. Yeah, thanks for questions. And yeah, thanks for listening.